previous session, we were discussing about the voltage gradient cables and some other general applications of different cables. In this session, we are going to continue with some more parameters, some more the materials that we are using in our distribution system. In this, now we consider the main switch and distribution boards. Here, according to the Indian Electricity Rule 50, a linked switch must be provided after a meter board. That is, we in the previous model we studied the different Indian rules. In that, the rule number 50 says that a switch must be provided after the meter board. That is, first from the service mains lines, the line should be connected to the meter board. From that meter board, the next wires should be connected to the distribution board. So in between that, a switch must be provided after the meter board. That is before the distribution board. That is, a fuse or switch must be provided between the meter board and the distribution board. And the cutout must be provided after linked switch to protect circuit against the excessive current. That is, if some excess amount of current is flowing, that is flowing through our wires, then a cutout must be provided in order to remove the our appliances from the excess flowing of current. That's why cutout must be provided as a switch to protect the circuit against the excess current. Next thing is fuse units and the switch units must be considered as one unit or separate unit. These are the different switches and switch fuses. You can see that this is a closed link. These are the closed link. This is a frame. The frame which encloses the fuse and fuse units and cutouts. These are the two kind of fuses. That is a double pole ironclad switches and the triple pole ironclad switches. This is a double pole. Two poles are here. And this is a triple pole. Two poles are here. The disconnecting link. These are the two links which connects and disconnects the supply from the distribution side to the mains. These are the two operating handles. This is the cover which used to cover our switches and fuse links. And this is the same thing shown in other way, that is the cast iron casing. These are the kind of fuse links, fuse holders, and the DPIT and DPST switch distribution boards. This switch cover, this is the outgoing contacts. These two are the contacts which we get the outgoing lines. These are the three fuses. Use it for protecting purpose. This is the moving contacts. These moving contacts makes and breaks the circuits. And this is the operating handle which is used to operate our fuse boxes. Same in the other view, the same things. Next thing is the fuses. What are the main purpose of fuses? What is fuse? It's a simple and cheap device used to protect your electrical device against faults. A device which uses to protect our electrical appliances from any faults. And action of fuse is based upon the heating effect of electric current. So as we know that fuse is made up of some small wires or some materials, and based upon the heating effect. That is, if normal minimum current, that's the rating current of rated current is flowing through the wires, then there is no concept of heat comes. If the excess amount of current flows through the links or the wires, then the fuse may get heated up. Because of this heating effect, the fuse is working. The time for blowing out of fuse depends on the magnitude of excessive current. As that is, if the rated current, whatever the required amount of rated current is flowing, if that rated current is exceeded, it's more than that rated current, then automatically the fuse links blows. What are the different types of fuses that we can see? It's a supply main fuse, consumer main fuse, sub-circuit fuse, and point fuse. So supply main fuse, this is mainly provided by the supplier side. That is, from the distribution side, we get the supply to our home, and from there these kind of fuses are normally placed on the poles. So this is the main supply main fuse, so provided by supplier, fixed after the service meter. That is, we can see that kind of fuse is provided in our home, which is just after the service meter. So these kind of fuses are provided by the suppliers. The next thing is consumer main fuse. This is placed after the consumer main switch. It's in the distribution board. After the distribution board, MCB is provided for safety of our equipment. These kind of MCBs, that's a miniature circuit breakers, circuit breaker is also a kind of fuse. So this is a consumer main fuse. The next thing is sub-circuit fuses. A separate fuse is provided for each branch circuit. That is, the circuits are divided into different sub-circuits. How we need to divide the circuits into sub-circuits, we will discuss in the next sessions. But for just the time purpose, just you people need to remember that a sub-circuit fuse is the fuse which we can places for each sub-circuits. So different sub-circuits will be placed in our location in our home, and for each sub-circuit we will place a one single fuses for protection of each sub-circuits. The next thing is point fuse. A good quality indoor wiring of building, every light and plug point is provided with individual fuses. That is, if you need to make good quality of wiring at the indoor, then we need to provide each fuse points. That's why every light and plug point is provided with an individual fuses. So next thing is how we need to determine the size of fuse. So the factors responsible for the determination of size of the fuse are maximum current rating of circuit and current rating of smallest cable in the circuit protected by fuse. So what it mean by maximum current rating of circuit? A circuit may be contain different points. Points means just a lighting point, a fan points or sockets. These are different kind of points. If before going for selection of a fuse wire, we need to calculate the how much amount of current we need to pass through the circuit. How we need to calculate this? We have to calculate first the total load of the circuit. By dividing the load with the voltage, we will get the current. Based upon that current rating, we need to select the fuse wire. That is, first we need to calculate the load of the circuit, then we need to calculate the current with the help of voltage. According to Ohm's law, we know that I is equals to R by V. So then from the load we have calculated with the help of voltage, we will get easily rating of current. Then current rating of smallest cable in circuit protected by fuse. Current rating of smallest cable in circuit protected by fuse. A circuit contains many number of wires. In that wires, we need to make sure that the selected wire is of smallest cable. This cable is the wire with the insulation. This smallest cable must be protected by the fuse. Like that, we need to select the different sizes of the fuse. And here we can see that this based upon the current rating fuse amperes and the approximate fuse current amperes. And this is the diameter in meter. This is the length of the diameter of wire which we need to select. This is the standard wire gauge. This first column is the standard wire gauge. For example, the rated current rating of the fuse in for the approximate current rating. If the current rating which I have calculated is of about 6 amperes. 6 amperes. See here, this is 6 ampere. Then the wire should the standard wire gauge of the selected wire should be 33, and this is the diameter in inches. There is a 0.01 inches. This is 2.254 millimeter with approximate fusing current is 10. How it is differs? Here the current rating of fuse is in 6 ampere, but the approximate fuse current is 10 ampere. That is, if I am calculated the load current, it gives about 7 amperes. For example, if it gives 7 amperes, the selected fuse must be able to pass the current up to 7 amperes. But if there may be some sudden variation of the loads or sudden variation of the voltage drops, for that purpose we need to make sure that just a point less than that point, that is 6 ampere of voltage current fuse must be selected. But there will be no exact rating of the fuses for 6 amperes. That varies between the 10 and 6 amperes of current. Like that, we need to select the ratings of the fuses. Mainly, we need to select the fuses based upon the maximum current that it can withstand. A particular wire should be withstand. If it crosses the more than that fixed amount of current, then automatically it should be breakdown. Like that, we need to select the exact rating of the fuse current. And next thing is the fuse units. We need fuse units for the purpose of to hold the fuses. The fuse unit essentially consists of metal fuse elements, set of contacts, body to support. Fuse unit, the whole fuse unit consists of metal fuse element. This is a metal fuse element. What is meant by metal fuse element? That is just we studied that wires, fuse wires, or some chemical content, or some powder like chemicals. These are some different kind of fuse metals are there. So those are also comes under the fuse units. These are different fuse elements. A set of contacts. Contact links will be placed. Show you the contacts. See here. See here. These are the fuses. These are the contacts. Fusing contacts. And the holders, fuse holders. Here, this is the fuse. This is the in between that a contact will be there. And this is the fuse holder. All the three combinedly called as fuse units. Set of contacts and body to support. So based upon the different types of units, here we are differentiated that a round type fuse unit. What is meant by this round type fuse unit? It consists of a porcelain or a bracket box and two separated wire terminals for holding the fuse wire. Two separated fuse holding wires, metal strips are there. In between that, fuse wire should be connected. And this type of fuse is not in common use because it's under these are over fashioned. So in today's plannings, we are already removed these kind of round type fuse units. What it means, two metal pieces will be placed in the fuse units. Between the two metal strips, a fuse link, a fuse wire should be placed. The next thing is KitKat type fuse unit. This is also in the KitKat type fuse unit. Holders, fuse holders are made up of normally ceramics or cements. Sometimes these are also made up of good quality insulating materials. And the most commonly used in these kind of fuse units are most commonly used in our home appliances. A small current circuits is the semi-enclosed or rewirable fuse. It consists of a porcelain base carrying the fixed contacts to which the incoming and outgoing live or phases. The incoming and outgoing phase lines or phases are connected, and the porcelain fuse carrier, the whatever the unit that we hold in our hand, that is a fuse carrier, porcelain fuse carrier holding the fuse element, and it consists of one or more strands of fuse wires. These kind of fuse units we can you people are observed in your distribution boxes at your homes, and these are the called as KitKat type fuse. The next thing is cartridge type. It's a cartridge type. Cartridge type, this is a normally enclosed type of fuse units. These kind of fuses are enclosed. It's not visible for our directly visible. These are enclosed in different equipments, and it is essentially consists of insulating containers of bulb or tube shape, and selected it ends with the metallic caps. These are the cartridge type fuses are looks like a cartridge, and it's a tank like structures. At the end, two metal strips will be provided, which are the links to the service mains, and the which are links to the two incoming and outgoing lines. So and these cartridge type fuses are normally filled with the powder or granular material known as fillers. These are filled with the fillers. These are known as powders or granular materials. And there are various types of materials used as fillers like sand, calcium carbonate, quartz, etc. So these are looks like a exact cartridge bullet. So that's why the name came as a cartridge. It contains the fillers normally made up of. These fillers are made up of sands and cement like structures, quartz like structures, etc. And at the end points, the metallic strips will be connected, which are the links to the incoming and outgoing lines. The next thing is HRC fuse. HRC fuse are high rupturing capacity fuses, and with a heavy generating capacities of modern power stations, extremely heavy currents would flow into the fault. So these kind of fuses are normally used in our substations where heavy currents passes through the circuits. In that, like that circuits, we use HRC fuses. And fuse clearing the fault would be required to withstand the extremely high stresses in this process. Extremely high stresses of current where we are getting, in that places we use high rupture capacity fuses. And that is about the rupturing capacity is as high as 500 MVA up to 66 kV and the above. That is 500 MVA current transformer units and substations. That is the places where we see the transformers of 500 MVA. In that places we can see the HRC fuses, and the places where the voltage levels of about more than 66 kV is passing, in that places also we can see the HRC fuses. The next thing is semiconductor fuses. These are very commonly used fuses in our electronic equipments. In these semiconductor fuses, we normally see the diodes and transistors. Diode can be used as a fuse, and transistor can also use as the fuse. Small metal strips, small tubes will be using. In that, two metallic strips will be connected at the end of the two fuse units. In between that, metallic wires or metallic links will be connected between the two metal strips, which is acts as a semiconductor fuse. The next thing is earthing conductor. So after all these things, we need to make sure about the earthing. The high conductivity copper standard or flat strips or circular or rectangular bars. This is the earthing conductor, is normally made up of copper or aluminum, and normally copper will be used for daily appliances. And here copper which we using should be of high conductivity, and stranded or flat strips. It may be a conductor of size stranded or flat strips or circular or rectangular bars. These are the different shapes of earthing conductors which we can observe, and they are connected like not get damaged accidentally. They should be connected in such a way that they should not be get damaged accidentally. In order to provide better conductivity and better protection of our equipments, we have to make sure that the earthing conductor should not fail at any cost, and it should not be get damaged accidentally also. Like that things we need to consider while selecting the good earthing. And aerial earthing conductor is supported on the suitable insulators. You can observe in the aerial earthing conductors also, where it's normally placed at the poles and with the help of suitable insulators. You have to use suitable insulators for that purpose. They are fixed over their entire length by clamps, clips, saddles, staples, clouds, etc., which in no way damage the conductors. It should not be damage our actual conductors. And aerial earthing conductor is supported on suitable insulators and is clearly identified. Which are these kind of earthing conductors should be placed in such a place that they should not be get damaged easily. And, there are some different general rules are there. While these are main, actually these are the important rules which we need to observe, which we need to learn before going for estimating, costing or installation of our wiring systems, that we will discuss in the next session.